Welcome to Mastering Solutions. We have another circular motion problem here, and they tell us that the moon completes one circular orbit of the Earth in 27.3 days. They give us the distance from the Earth to the moon of 3.84 times 10 to the 8 meters, and they want us to find centripetal acceleration. Let's write again the formula for acceleration, which is, of course, with circular motion, velocity squared over the radius. Another formula that we'll need is the velocity formula. So the velocity with circular motion is equal to 2 pi r over the period. And another way that we could express that is 2 pi times the frequency times the radius. Because if you remember, 1 over t is equal to the frequency. So these are all saying the exact same thing. I'm going to be using this form of the equation right here. And what we could actually do is we can actually substitute t for the time. So we have 2 pi times the radius over the change in the time. That just applies to this question because the time that they give us, 27.3 days, is the period. The period is how long it takes to do one complete revolution. So we could leave it as t, or we can change it to delta t. It's meaning in this question the exact same thing. What we need for acceleration is the velocity squared. So let's square all of this. First, let's rewrite it. So v squared is equal to all of this squared. So 2 pi r over delta t squared. So that's going to give us 4 pi squared r squared divided by delta t squared. Now when we plug this in up here for the velocity, what we'll end up with, let me change colors while we plug that in. So acceleration will be equal to 4 pi r squared over delta t squared times r. We can simplify the radius. One of these will cancel to the one on the bottom. So now what we're left with finally is acceleration is equal to 4 pi squared times r over delta t squared. And now we have our formula finished, but we need to convert this unit right here into standard units. We have standard units with the radius, or the distance from the moon to the Earth, because the Earth's right here and the moon is orbiting around it. So the distance here that they gave is the radius, but this is in days and we want it in seconds. So for 27.3 days, we know that in 1 day, there's of course 24 hours. And then in 1 hour, there is 3,600 seconds. This came up a lot in chapters 1 and 2. It's a really good unit to remember. It saves a little bit of time on tests. So we'll have 27.3. And then we'll multiply that by 24 and multiply it by 3,600 to put us in seconds. So we have 2.36 times 1, 2, 3, 4, 5, 6. So we have 36 times 10 to the 6 seconds. And now what are we trying to solve for again? We're trying to solve for the acceleration, right? So let's plug in all of our values now into the acceleration formula. So acceleration is equal to 4 times pi squared times the radius, which we said is 3.84 times 10 to the 8 meters. That'll all be divided by the time, which is 2.36 times 10 to the 6 seconds, and that will be squared. So we have 4 pi squared times the radius, which is 3.84 times 10 to the 8. And then we'll divide that by 2.36 times 10 to the 6, and then all that'll be squared. So let's change that to scientific notation. So now when we come back out, we have 2.7 times 10 to the negative 3. So we have 2.7 times 10 to the negative 3 meters per second squared is the centripetal acceleration for the moon as it orbits around the Earth.